Afternoon, everybody. Welcome to our last set of sessions here on this third day of PyCon. Today, this afternoon, we're going to start off with a talk on systemd, why you should care as a Python developer. Let's give a big hand here for Alvaro. And sorry, one thing, we will not have time to take questions as part of the session, but if you do have questions, you can catch Alvaro afterwards outside. Thanks.
Hello. Okay, let's start. As my friend over here already said, I'm Alvaro. I'm a production engineer at Facebook and Instagram, and I'm here to talk to you about systemd and why should you care as a Python developer. Before we start, I have a couple of things to say. The first thing is that this is my first PyCon talk. And of course, the day before my talk, I lost the complete use of my voice. So now you hear me like this is just because I'm struggling. Yesterday I was completely mute. Today I'm kind of like Phoebe in that one episode of Friends where she could not talk. So yeah, so that's the first thing. So that's why we're not going to have questions here because nobody wants to hear more my voice. The second thing is that this presentation is going to be two parts. The first one is going to be a slide where I just say like what is systemd, a few cool things that you can do. And then I'm going to go into a practice mode where I'm going to show you code where you can do the part like, why should you care as a Python developer? That's kind of the point of the talk, right? We're PyCon. OK, so with that out of the way, let's start. Systemd is many things to many people. And in general, we want to treat systemd as a service manager. So the first thing that we need to ask ourselves, what is a service manager? As the name implies, a service manager is something that manages your service. That means that it's not your service by itself. It's not Apache. It's not Nginx. It's the thing that allows you to operate your service. Start, stop, reload, restart. It's also the thing that is supposed to manage the life cycle of your service. So if you want your Django application to start at boot, but only after your Postgres server is already ready to run, that's the job of your service manager. So in the good old days, that means the time before systemd, there was no real service manager per se. So you have to be your own service manager. And the way that you do this, it's you wrote shell script that, I hope that looks good, but where basically in this shell script, you define the operations that you needed to do. For instance, here you have start, stop, restart, and for some reason, force reload is the same thing as restart. And you wrote this in shell. This was viewed as a good thing in general, because if you are writing shell script, that means that you can write whatever you want. If you want to start your service in a certain way, nobody's telling you how to do it, you have to do it by yourself. The problem with freedom in this sense is that, for instance, in that weird section over there that you see, the only line that's actually starting the service is the line 110, and everything else is just boilerplate code. You have argument parsing, you have print output, and all the things that you needed to do to make a fully functional program. And you do this for all of your units on your server. So this was good, but yeah. So then came systemd. It was obvious for a long time for the Unix community and other architecture communities that even though System 5 was good enough for what we have, we needed a change to be able to grow servers faster, have better startup times. So as always happens, at least two things arise. One was Upstart, the other one was systemd, and probably I'm forgetting the one service manager that people really like, but yeah. So these two were like the big one, and as usually this happened, they went into a little war, and systemd at the end won, basically. And by won, I mean that is part of all major distribution. I'm not saying that it's better, I'm just saying that it's there. So that's kind of the first spirit that I want to show you, and that's the spirit of this talk. It's not is systemd good, is systemd bad, it's more like systemd is a fact of life, it's part of your server, it's part of there, how can we use it to do our things better? So what makes systemd so different, so love and hate for many people? Basically, where you used to have shell script, now you have unit files. So you now don't have executable things, you just now have declarative things. Basically, you write this unit file, and if you're running a service, it's called a service file, where you specify how your service should look like, and then you let systemd configure your service as it should. So this is not executable. You cannot just dot and run that file. So you need something to execute it. And I really hope that looks good. But yeah, so if you want to start your service, you ask systemd to start it for you. You don't do it yourself, and this is a completely change of paradigms. You say systemctl start my service. If you want to stop it, you do systemctl stop my service, which, if you remember, like I didn't specify how to stop my service. But since this is a Unix service, systemd kind of know how the thing should be done. So I didn't need to write that algorithm. But if you really ask me, the reason why I think systemd is the de facto init system or service manager on most services, on most servers, is because if you ask for a status, for information for your service, it gives it to you. And this is something that you think like it's obvious, but it's before systemd was not possible. Things like, is my service running? It makes sense that systemd can tell you that information because systemd starts your service. So he creates the first fork exec. He knows the PID of your main application, so he can keep track of it. He can tell you when your service starts. And now you know that these two things are actually real. In System 5, when you ask service, the name of the service status, it says running. But it didn't tell you like when or all those information. It also gives you a little piece of data that before systemd was actually not possible to get entirely. That is all the processes that are running within your service. And I explained this right away when I explained the concept of cgroup. So this would not be a systemd talk if I did not talk about two things. The first one is socket activation, and the second one is cgroup. So let's at least tackle one. A cgroup, a cgroup, it's basically a Linux kernel feature that allows you to impose restriction on a certain list of processes. So in common language, it's like I have a process and I want to say you can only use 40% of CPU, 10 megabytes of RAM, you can only access this type of memory or CPU I/O, or I/O like disk I/O. That's what cgroups allows you to do. Systemd use cgroups for this purpose, but also for a slightly different purpose. So systemd, before starting your service, it will create a cgroup just for that service. So system/myapp service, that's the name of the cgroup. And the convention of is systemd specific, it doesn't have to do anything with cgroups, it's just a name. So then start your service. Then, if your main process start two child processes, these child processes are also going to be part of the process tree. So if you go into the main process and then look at the process tree, you're going to see these two child processes. But you can also, instead of doing that, go through the cgroup and then list all the processes on the cgroup, and you're still going to see them. But here's where it's cool, because if one of the child processes decides to double fork itself and then demonize and escape the parent, it will no longer be part of the process tree. So in a regular point of view, you will lose sight of it. But since it cannot escape the cgroup, systemd can still tell, like, that daemon spawned by main process is part of the service. So for the first time in all of Linux history, we were able to actually kill a service in its entirety. Because now we don't have to keep track of individual process. We just say, cgroup, goodbye, and then everything goes. So I hope you like my explanation of cgroups. Let's move on to, now, what cool things can we do with systemd? So the first thing that I want to show you is template. And so a template, and again, I hope this looks good. A template is basically a unit file, the same, but instead of having the name myapp.service, it's myapp@.service. And then in your file, you put this percentage %y. So then when you want to start your service, you start your service as myapp@ and then a word. Doesn't matter which one it is. In this case, I put the configuration name. So what systemd will do is that it will replace that %y with the word that you put there. So this is cool because if you have, for instance, this is uWSGI, which I'm pretty sure most of us are familiar with. If you have uWSGI the configuration point to different version of your app, you can actually do rollup with this. So you can start my app at version 1 conf, and then start my app at version 2 conf, have two of them running, do your A/B testing, and when you decided that one is good, you take out one and leave the other. Or you can roll back by just stopping the other one. So this is actually a cool feature that it usually gets overlooked as a toy thing, but it's really powerful. As I said, this would not be a systemd talk if I didn't talk about socket activation and cgroup. Let's talk about socket activation. I'm gonna say something that is obvious to everybody, and it's like, when you don't do socket activation and you want to do network, you start your application, then eventually your application will open a port, will start listening to the port 80, and then this port will become an open file for your application. And this little piece of data is really important. Then you will get a request, and then you will send back a response. This thing has an implicit contract that since the port is an open file of your application, if your application goes down, the port is closed or it's not listening or whatever you want to name it. So if somebody sends your request, you can send an answer. So socket activation changes the logic of application port request. In socket activation, systemd will start and he will start listening to your port. So instead of you starting to listen on port 80, systemd will start listening to you. And opening a port is basically lightning fast. Then you will get a request. So you have port request. And only when you request, systemd will activate your service. So socket activation, you get it. And then systemd will just gladly pass the file descriptor to your app. So this file descriptor is something that has already been binned and has already been listened to it. So your application, all it needs to do is read and accept the connection. And then you can send the response back. This gives you a lot of flexibility and options. The first one that it allows you to, not even in production, but in your dev server or in your laptop, if you're developing and some of your develop use MySQL as a backend, you don't have to have MySQL always running. You just have it running the first time that you hit a test that will go into your MySQL. That's kind of the point. So save resources and only activate the stuff that you want. The other thing is that since this program that listens to the port and the program that actually accepts the connection are different, you can start your program as root. And I'm assuming that everybody renamed his root user as Guido. So, okay, so bad jokes. If you like bad jokes, this is going to be the presentation for you. Okay, back on track. Systemd will start your port, and since systemd runs as root, it can be into any port in the system. But then your application can run as a normal user. And the cool thing about this is that without this, your application has to start as root, bin to the port, and then either drop privilege or start a process with a different user. Right now, the application from the beginning doesn't have all the privileges that it wants. So that's another thing that is cool. And finally, if you run on modern Linux, you can use SO port reuse, and then you can have, for instance, running the first version of your application, like I say, and then you can ask systemd to start the second version of your application, but also listening to the port. So this is an option of the kernel, like SO port reuse. I won't go into it, but go and dig it because it's really cool. So then you will have your two applications running, and again, you do A/B testing, and when you're ready to say that version 2 is up for production, you just made it the final one. Cool. So how do we make this possible? It's simple. The service files remain almost untouched. The important thing is that now you create a socket file where you specify what do you want to listen, and you start that socket file as you will start any service. Now, in your code, since you would normally do open a socket, bin to a port, and execute a listen. Since all these things are already done for you for systemd, what you need to do is, instead of doing that, you just socket from fd. Instead of socket.socket, you open a file descriptor. And that file descriptor is the one that was handed to you by systemd. And you see that there is a library there that's called pistemd. And that's my library that I created. So segue into my library. And Python, in Facebook, we use a lot of Python. And we use a lot of systemd. So basically, we created a library to be able to interact with systemd in a same way that doesn't involve executing subprocess.call all the time. So we basically do a DBus interface to systemd. How does it work? I'm sure that everybody can read that great thing. You pip install pistemd. I hope that's better. You import it as you would normally import it. And then if you have a unit on your service, you just load it like that. And then you can start and stop. and do all the operations that you want. Nothing fancy there. If you want to get information from your running service, you can also get it. So for instance, you can get the main PID. And since this is not executing a shell and then parsing the text out and giving you something, that main PID is an integer. Because we talk over divas, divas knows about types, so you get it, it's cool. And if you want to get like the list of process, you can get it. And that concludes the first part of the presentation. I'm going to move to a demo. So we're going to abuse systemd with systemd. And I want to show you a few things that can or cannot make I hope, yes. Okay, so in your normal application, if you want to execute a shell command, the thing that you will do is process.call, right? So for instance, if I want to execute sleep, I will execute it, and then you will see, like right there, that is a child of the parent process that I created. This has 3 consequences. The first consequence is that it's run as the same user of my application. That means that it has all the same privileges that my application has. The second thing is that it runs as the same C group, so it has the same view of the system. And the third thing is that it has the, if the parent goes away, the children also goes away. So running a process sounds a lot like starting a service. So instead of doing that, systemd provides a nice feature that is called a transient unit. So instead of me starting a service, that means creating a unit file and reload it, I can actually execute systemd.run. The first thing that you saw there is that it returns right away, and it returns what it's supposed to be, a unit file. Let me store that. The second thing that you see is that it's created as its own process. It's not part of the process tree, it's away. So this is cool, because all this restriction that we just took goes away. I'm going to go as far as say that almost all the calls that you make to subprocess.call in your service can be replaced with systemd.run on Linux. Don't do this on Windows, it will not work. On other things different than Linux. But yeah, so that's cool. Okay, so let's see what happened. So the thing that happened is that systemd actually created a unit for me, and it started as a different service. That means that if I go here and just cut that file, you will see that it gives me a unit file that I didn't create. And as it should be, is in run systemd transient unit. So, so with this, I can execute stuff with systemd.run, see the unit file that got created, and then I can see how I can do the same thing with my normal service. So let me go there. Okay, cool. What other cool things can we do? So this is one thing that I think it's cool, and is like I can actually start a batch process. So if you see, I'm still on my mini demo right there that you see. But for some reason, I created a batch process. I added a PTY, and then I linked together the std in and std out. Really magic, and I only did it with this command over here that you can see. You see, this should give you a little better. So std in, std out, PTY true, and I give it a name. And I give it a name, and here I can show you you see the service unit that would be created for that. So this is a normal shell, and I can do stuff like and actually verify that this is what I'm running. So I can do all this kind of stuff. And here is the first thing that I think why systemd.run is better than subprocess.call for some things. Is that I can do with this, if I want to run this as a different user, right, all I need to do is just add user at the end and then the name of the user. And then, as you see, my shell, it's running as the background user, and this is how you accomplish that. If you, instead of doing from systemd.call, you start from a service file, this is how you will do it. So this is actually cool, because now in your program, you can execute pieces of code as unprivileged. So let's see what other cool things can we do. And I will start going relatively fast until I run out of time. On showing different settings. These settings, you can use it in any combination that you like, and most of them have more different versions of configuration. But the ones that I'm showing you are meant to give you curiosity and go and read the man page, see all the blog posts, send me messages on Messenger or Instagram. If you care about my cats, I don't have cats. I have dogs, sons. Yeah. Okay. Hi, sons. Okay. Okay. So the first one is protect home. Protect home is actually quite a good idea, and the logic is the following: you start your Django application. Why would your Django application have access to the SSH keys or the AWS credential to your users? So what Protect Home does is that it literally will take away for your service, just your service, it will not have anything underneath home and root. So that means that now if somebody hacked your service, it got limited exposure to your application. And that, if you ask me, I think it's really cool. Now, Django, and I say Django because I'm Instagram and we work a lot with Django. Django has one thing where it just read templates, read data from backends, and then expose it to the wire. So it actually doesn't need to write information into disk. So the second option is protect system strict. And what that does is that it tries to make your whole system read-only. So that way, your service, only your service, cannot write anywhere, not even in temporal directory. Of course, you can modify this, and there are different options, but yeah. So this is one cool thing that you can do. Okay. So the next one that you can do, it's a little longer, and I just put all of them together, is that even though protect home and protect systems are cool, they are really like a catch-all bag. Like sometimes I want to have a few pieces, not all of them. So you can have like a part of that. One part is you can have read-only directories. So I can specify which directories I want to be read-only. So I can say root directory, you can read it because I need you to access my AWS credentials, but don't write into it because don't. Inaccessible directories is the same thing that you saw, it just goes away. And read-write directories, I don't have to explain it, it's just obvious. Okay, private TMP, it works awesome because for your service, it gives a private version of what would be the TMP directory. So we don't share the same TMP as the rest of the system does. So you can put stuff there, or other service can put stuff on their TMP, and they won't collide. You can do the same thing with any directory when you specify with temporal file system. So if you see, it will mount var cache MyS as a temporal file system, as a tempfs. The cool thing about these two features is that once your service is down, all the temporal files that you created are also going away. So this is one of the privileges that you have when you let systemd manage your service. The two last ones that I have here, it's one thing that most people don't know that they can do. You can bin path for your application. So what I can do is, for instance, I can believe my application that var lib cache MyS lib over there is actually SRV PyCon. So these two directories are actually, but only for my service, not everybody else. And then you can read-only path. It's, of course, you mounted, but mounted as read-only. But here's the cool thing. What I mounted here is not a folder. It's a file. So you can also mount files. And you can also do this with mount operation. The problem is that that idea is kind of weird to people. To me, it's also weird. But yeah, so you can do that. Let's move next. Oh, this one is cool. And I'm glad I still have time to show you this. So how about, we talk about disk, we talk about permissions. How about network access? So what this does is that I'm running batch, and I have there, you can tell to your service, and just to your service, hey, I don't want you to access anything on the internet, or anything access you, except IP 888.32. So now what I have here is an application that can only, we can do more than ping, but it can only ping 888. Sorry. And if I try to point 44, it will tell me operation not permitted because I cannot even create it. So you can have a firewall just for your service. This is systemd. Systemd only gives you access to it through Python. It says, I don't do anything special about it. So that's cool. There are other options more restrictive to that, but that one was cool. And then the cool one, again, this is systemd. These are C groups. Let's see how systemd uses C group. Here I have a unit that basically I said use 20% of CPU, only use 10 megabytes of RAM, and you're only allowed to spawn five processes. So let me show you what that means. So right here, if you see, I have the memory limit and then the task limit. The task limit means that I can only have up to 5 running processes at a certain time. Or let's say like this, I can only fork 5 times at a time, if that makes sense. Okay, the only one that I want to show you here to explain, it's the CPU. You have to believe me that the other ones work. So I will do a simple Python program that I have been doing since I learned to code. That is just basically using all the CPU that I can. So if you see, right there, is that I'm trying to use all the CPU that I can, and if you see that nice number that doesn't go too much above 20, rounding, stuff like that. Accounting is not really the best thing that you can do, but yeah, so it goes like that. So that's how you restrict. And, I will do something. I will try to overflow. And if you see there, it says kill it. So the machine, it was also smart enough to know that this is the thing to kill because this is the one that is actually violating your things. And I'm going to go to a nice stop here. There are more things to show. I just want to show the last thing, but I won't explain it. Oh, of course, something has to go wrong, and yeah, we're done. Thank you. That was it. How many? Okay. Honestly, I'm here for questions. I just not on stage. Yeah, so ping me if you have anything. Thank you guys for coming.